All right, so our project for biomedical technologies is on impact-resisting gloves. I am Matin Farhangmehr.
And my name is Gannon.
So the introduction and the purpose for our project, we both work physical labor jobs, and we needed gloves to help resist the impact and the stress that it puts onto our hands. So our idea was to design gloves to limit impact on the job. Our final conclusion as to what we wanted to design for this project was we wanted to design a padding on the interior of the glove to help with impact resistance. And we wanted to create this using design software and 3D printing.
So our idea was that supports inside the glove would make contact with the hand and distribute the force over a larger area, so you would feel it less pinpointed and less direct on your hand.
So for the design process, Pierce will go more in depth in this video coming up.
So for the basic prototype, we would like to have a raised platform across the entire palm, as well as specific raised portions to reduce the impact on each of the joints at the start of the fingers and the edges of the palms. So to make our design, we had to measure the palm of the glove. We had to measure across this way, which totaled out to about 3.5 inches, which was a little bit too big, but we scaled it down just a tiny bit. And we had to measure each of these pads on the glove, which we did here by tracing and just measuring with some crude lines and drawings. And then right here as well, as you can see right there, we have a little edge that we cut out because the glove padding doesn't quite extend all the way over. Chose to use DesignSpark Mechanical, not only because it's I feel the most efficient, but I'm the most familiar with it. But one issue we did run into is that when the files need to be saved, it saves them as an RS-doc file, but we needed an STL, so we had to jump through some hoops, but we eventually figured it out, and that allowed us to print at the DFX lab. So
for the printing process, we went over to the DFX lab, and as said in the previous video by Pierce, that we needed to convert the RS-doc file, which is what DesignSpark Mechanical puts it as the default, into an STL file to put it into the DFX lab. We used a flash drive to put it into the flash print, which is the software that we used in the DFX lab, as shown in this picture right here. And the used material for the DFX lab was the thermoplastic. And our final results are these two pictures, are shown by these two pictures right here. So then, after we created the padding, we took 3 volunteers and we asked them to catch a ball and to lift a couch, which are 2 normal physical labor jobs, and we wanted to test the durability, comfort, and most significantly, the impact resistance. So as you'll see in the video, these 3 volunteers each did those activities, and then at the end give their input and criticism of what could have been done better and what they liked about the glove padding.
So for the ball, we had them catch it in the normal glove without padding as a control test, and then also catch the ball with the padding, and just to compare the two, see how they measure up.
As we will get back to the last one, and then each of them will give their input on their feeling of the glove.
Definitely helped with the impact, however, the mobility I've been lost as a result was very detrimental. So, but yes, it worked in the fact that it definitely dulled it.
Non-padded glove allows me for more dexterity and mobility, comfort of movement. However, the padded glove does function quite well as like an armored impact resistant surface. However, my qualm is that I feel that it limits my mobility and comfort of movement.
In regard to the objects with velocity, the glove had a substantial difference in terms of the level of comfort which came with that.
So for future work, because it wasn't quite perfect as you heard in those videos, we would like to make a design that curves more with the hand, possibly using 3D scanning to get a good image of a hand and really get a model that kind of fits as opposed to something that's just stiff. So that would help a lot with comfort. And we would also like to use thermoplastic rubber, which would also help with the comfort and the stiffness, because that would absorb more impact as opposed to just a hard plastic. This one kind of bends and flexes and helps redistribute those forces more evenly. We've also made it a little bit smaller. We have a new design which we are hoping to print very soon that is a little bit smaller and hopefully will fit inside the glove a little bit better, as well as being thinner to provide more flexion.
And with that being said, I am Matin Farhangmehr,
And my name is Gannon.
and this was our project for Modern Biomedical Technologies.